Good morning, everyone. I'm Steve.
And I'm Scott.
Together, we're Backyard Musings broadcasting in Valley, California.
Science and Technology Channel.
Juno's latest discoveries have pulled back the veil on Jupiter's harsh atmosphere and the fiery volcanic world of Io. The spacecraft detected warm lava flows beneath Io's crust and uncovered how heat flows like a cosmic radiator across its surface. Meanwhile, Juno's radio signals revealed chilling new details about Jupiter's polar temperatures. No pun intended, chilling, right?
Got it.
Okay. While long-term tracking of massive cyclones around the pole showed them drifting and bouncing off each other in bizarre ways, NASA's findings were presented on April 29, 2025 during a news briefing at the European Geosciences Union General Assembly in Vienna. Would you like to know more about Juno?
NASA's Juno spacecraft has uncovered striking new details about Jupiter and its volcanic moon, Io. By looking beneath Jupiter's dense cloud cover and deep into Io's surface, scientists have developed a more detailed model of the fast-moving jet stream that surrounds Jupiter's North Pole. At the same time, they've achieved a first, mapping the subsurface temperature of Io, revealing important clues about its internal structure and ongoing volcanic activity.
It's like Mustafa, the planet of Mustafa, where Darth Vader had his limbs cut off.
Oh, that must have been in 1, 2, 3, or 7, 8, or 9.
Yeah, Revenge of the Sith. It was. Okay, quote, everything about Jupiter is extreme. The planet is home to gigantic polar cyclones bigger than Australia.
Wow, that's a massive storm.
Well, I mean, it's a massive planet, so... fierce jet streams, the most volcanic body in our solar system, the most powerful aurora, and the harshest radiation belts, said Scott Bolton, principal investigator of Juno at the Southwest Research Institute in San Antonio. Quote, he continues, as Juno's orbit takes us to new regions of Jupiter's complex system, we're getting a closer look at the immensity of energy this gas giant wields.
Bless you. Although Juno's Juno's microwave radiometer MWR was designed to study Jupiter's deep atmosphere, the mission team also directed it at Io, teaming it with data from the Jovian Infrared Auroral Mapper, JIRAM. JIRAM?
JIRAM.
Call that? Okay.
Yeah.
For a more complete view of the moon's fiery interior.
Quote, the Juno science team loves to combine very different data sets from very different instruments and see what we can learn, said Shannon Brown, a Juno scientist at NASA's Jet Propulsion Lab in Southern California. She continues, when we incorporated the MWR data with the GIRAM's infrared imagery, we were surprised by what we saw, evidence of still warm magma that hasn't yet solidified below Mustafa's cooled crust, or Io. At every latitude and longitude, there were cooling lava flows.
The data suggests that about 10% of the moon's surface has these remnants of slowly cooling lava just below the surface. The result may help provide insight into how the moon renews its surface so quickly, as well as how well heat moves from its deep interior to surface. Io's volcanoes, lava fields, and subterranean lava flows act like a car radiator, she said. This is according to Dr. Brown, right? She's a doctor?
Yeah.
Efficiently moving heat from the interior to the surface, cooling itself down in the vacuum of space.
Yeah. I guess is it getting bigger if that lava's coming up and it hardens?
So
growing?
Expands and contracts.
I don't know, maybe. Looking at GIRAM data alone, the team also determined the most energetic eruption in Io's history, first identified by the infrared imager during Juno's December 27, 2024 Io flyby, was still spewing lava and ash as recently as March 2nd. Juno, that would be awesome to see, wouldn't it? That'd just be awesome. Juno mission scientists believe it remains active today and expect more observations on May 6th. So Juno is going around Jupiter. What it's doing. When the solar-powered spacecraft flies by the fiery moon at a distance of about 55,300 miles.
Wow. On its 53rd orbit, which was back in February 18th of 2023, Juno began radio occultation experiments to explore the gas giant's atmospheric temperature structure. With this technique, a radio signal is transmitted from Earth to Juno and back, passing through Jupiter's atmosphere on both legs of the journey. As the planet's atmospheric layers bend the radio waves, scientists can precisely measure the effects of this refraction to derive detailed information about the temperature and density of the atmosphere.
Only rocket scientists could do that, man. I mean, how do they do that? How do they think that up?
I don't know.
Let's send a signal,
man, that's
bounce
what they
it
do.
back.
Yep.
Man.
That's what they do.
So far, Juno has completed 26 radio occultations soundings. Among the most compelling discoveries, the first ever temperature measurement of Jupiter's North Pole stratospheric cap reveals the region is about 11 degrees Celsius cooler than its surroundings and is encircled by winds exceeding 100 miles per hour. Can't live in that.
It's a breeze around here, right? The team's recent findings also focus on the cyclones that haunt Jupiter's north. Years of data from the JunoCam, Visible Light Imager, and GYRAM have allowed Juno scientists to observe the long-term movement of Jupiter's massive northern polar cyclone and the 8 cyclones that encircle it. Unlike hurricanes on Earth, which typically occur in isolation and at lower latitudes, Jupiter's are confined to the polar region.
I wonder why that is. That is just fascinating.
Yeah, I don't know.
Is that the big red spot too? All those cyclones together?
That's a good question.
Huh. By tracking the cyclone's movements across multiple orbits, the scientists observed that each storm gradually drifts towards the pole due to a process called beta drift, the interaction between the Coriolis force and the cyclone's circular wind pattern. This is similar to how hurricanes on our planet migrate, but earthly cyclones break up before reaching the pole due to the lack of warm, moist air needed to fuel them, as well as the weakening of the Coriolis force near the poles. What's more, Jupiter's cyclones cluster together while approaching the pole, and their motion slows as they begin interacting with neighboring cyclones.
Since arriving at Jupiter in 2016, Juno has delivered stunning data and imagery revealing the gas giant's dynamic atmosphere, deep storms, powerful auroras, and mysterious core, all while enduring some of the harshest radiation conditions in the solar system.
Yeah, so I wonder what they're doing for radiation shielding, like lead or something like that.
I don't know, but they built this thing pretty stout, right?
Yeah. And it's doing its job really well.
It is, these things are nothing short of a miracle how they can fly these satellites and communicate and get information back, and so far away, it's just astounding.
Crazy
stuff.
Yeah,
great
so
stuff.
Join us this afternoon. We've got a really fascinating segment on EMP, what happens during an EMP blast.
Yeah, not trying to scare anybody, but
right,
just if it happens.
Well, I mean, it's a possibility. It's good to know.
Right.
Good to know.
Yeah. Take care, everyone. Thank you.
See ya.